Hello guys, welcome back to another video. Today's our question is we have to compute the binary to decimal. We have to compute binary to decimal. Here we have been given a binary number and we have to print its decimal expansion. Okay, so you must be familiar about the binary number, that is in the form of that every binary number is represented in the form of ones and zeros, and we have to print its decimal number. Suppose if we are given 1001, so what would it be its decimal number? It is computed as 1 into 2's power 3 plus 0 into 2's power 2 plus 0 into 2's power 1 plus 1 into 2's power 0. This will be, what is 1 into 2's power 3? That is 8. This is 0. This is 0, 0, 0, and this is 1. This is finally 9. So this is 9 as our output. Okay, this is how we can calculate the binary to decimal. Okay, now we have to implement this code. So let's see how we can implement this code. So first of all, we require a number, that is a binary number from the user. So let's accept the number, enter the binary number. We are accepting the number from the user. Now what I need to do, I have to create one function that will compute the binary to decimal expansion. So we can write binary to decimal int n. Okay, now let me first clear this to you that though we are passing a number that is a binary number, but it is actually not a binary number, it is actually a decimal number. For us it is a decimal number, and for the machine it is a decimal number. Suppose if we pass 10001, so basically what's the task of machine or our computer? It's to encode our instructions to binary, and after that it will perform all the operations. But if we are passing the number input as 10001, so keep this thing in mind, it is not a binary number, it is a decimal number. Okay, so we have to compute or perform operation on this decimal number. It is not a binary number. Okay, keep this thing in mind. So now let's write this function. Let me first write, then I will explain it to you. Okay, so here I have write int I equal to 0, int decimal equal to 0, where I will store the result, and while n not equal to 0, and n here is a decimal number, not a binary number. Though we are taking it or assuming it to be a binary number, but it is not a binary number, it is a decimal number. So first I will compute the last digit, or we can calculate the last digit, int n is equal to n modulus 10. Okay, now what I will do, if last digit is equal to 1, now we'll perform the operation of decimal is equal to decimal plus power of 2 comma I. Okay, now what I will do, I will increment the I. Now I will divide the number again by 10. Okay, and finally I will print the decimal number. I will write it like decimal number is. Okay, okay, so let me explain you this how this logic is working over here. So here we have, suppose we have passed 10001 as our number. Okay, this number is a decimal number, right? It is, though it is a we are assuming it to a binary number, but it's actually a decimal number. Okay, now what we are doing, we are declaring two variables and initialize them to 0. Now this is the main logic what we are doing. So we have been checking if 10001 it is not equal to 0, so it will go into this while loop. So what it is check, it will check for the last digit. Last digit is 10001, it is, and modulus 10, it will give us 1. So this will give us the remainder, that is 1, if we do the modulus of with 10. Okay, now what we will do, we are checking that if last digit is equal to 1, yes, we are getting last digit as 1. Now it will go into the safe condition, and it will, what it will do, it will update this decimal which was initially 0 to 1 plus power of 2 comma I. What is this pow of 2 comma I? It will basically power of 2 to I is initially 0, so it will 1 plus power of 2 comma 0, so it will give us 1 as our output. Okay, now we have incremented the I to 1. Now our I is not 0, our I is 1. Okay, now number again with after that we have taken this 1 and does the operation for this 1. Now we will divide the number by 10. So now our number is 10000. Now what it will do, it will again go into this while condition, as it is not equal to 0. unless it is not equal to 0, it will go into this while condition. Okay, now the last digit, how what is the last digit? It is 0. So is the last digit 0? No, it will not. It is not equal to 0, so it will not go into this if condition. It will increment the I by 1. It now our I is 2, and it will divide the number by 10. Now our number is 100. Now what is I is 2? Now it will again go into this while condition. Now n modulus 10, it is again 0. So it will not go into this while condition, if condition. Now I will get incremented by 1. Now our I is 3. Now again the number will be divided by 10. Now our number is 10. So again then remainder will be 0. So again it will not go into this if condition. Now I will get incremented by 1. So our I is 4. So now now okay, now what it is, now our again the number will get divided by 10. Our number is 1. Now what we are getting is the last digit as 1. So it will go now into the safe condition. Our how our operate now our decimal is DEC is already 1 plus POW of what is our 2 comma i's value is 4. So we know that for 2's power 4 we get 16, and already the result decimal DEC was 1, so we will get 17 as our output. So this is the decimal expansion of the number 10001. So this is how the logic is working over here, and finally we are printing this decimal number after coming out of this while loop. So let's see if it's giving us the right output or not. So we will call this function binary to decimal for n. Now run this code. Okay, now we will give the binary number 10001. Yeah, we are getting 17 as our decimal number. So I hope you understood this. Let's give another binary number. Suppose 1000. So what is a decimal number? What is this 1000? It is basically 8 in decimal. So let's see if it is giving us 8 or not. If we give, yes, it is giving us 8. So this is how we can convert a binary number to a decimal number. One thing to remember, I am repeating it again, that this is actually a decimal number, but we are assuming it to be a binary number. Okay, so keep this thing in mind.